hi everyone. In this presentation, I will explain a galvanic cell constructed under standard condition using tin and chromium half cells. A galvanic cell is constructed using two standard reduction half reaction. The first half reaction is Sn2 plus aqueous plus 2 electrons producing solid tin with a standard electrode potential of a negative 0.14 volts. The second half reaction is Cr3 plus aqueous plus 3 electron producing solid chromium with a standard electrode potential of a negative 0.74 volts. Since the tin half reaction has a more positive standard electrode potential, tin acts as the cathode, while chromium acts as the anode. At the anode, the type of reaction that occurs is oxidation. At the cathode, the type of reaction that occurs is reduction. This follows the rule that oxidation occurs at the anode and reduction occurs at the cathode. At the anode, the chemical equation is 2 chromium solids reacting to form 2 chromium 3 plus aqueous ions and 6 electrons. At the cathode, the chemical equation is 3 tin 2 plus aqueous ion gaining 6 electrons to form 3 solid tin atoms. When both half reactions are combined, the overall chemical equation for the galvanic cell is 2 chromium solids reacting with 3 tin 2 plus aqueous ions to produce 2 chromium 3 plus aqueous ion and 3 solid tin atoms. At the anode, the observation for the solid electrode is that the chromium electrode dissolves as chromium atoms are oxidized into chromium 3 plus ion. At the cathode, the observation for the solid electrode is that the tin electrode becomes thicker because tin 2 plus ion gain electrons and deposit as solid tin. In the galvanic cell diagram, the chromium electrode is placed on the left side and is represented as solid chromium. The solution in the left half cell contains chromium 3 plus aqueous ion. The tin electrode is placed on the right side and is represented as solid tin. The solution in the right half cell contains tin 2 plus aqueous ions. The two half cells are connected by a salt bridge, and a voltmeter is connected in the external circuit. The direction of electron flow is from the chromium electron to the tin electron through the external wire. The correct cell notation for this galvanic cell is chromium solid followed by chromium 3 plus aqueous ion, then a double line followed by tin 2 plus aqueous ion and solid tin. This notation shows that the anode is written on the left and the cathode is written on the right. The standard cell potential is calculated using the formula E degree cell equals E degree cathodes minus E degree anode. By substituting the values, the standard cell potential is negative 0.14 volts minus negative 0.74 volts, which gives a value of positive 0.60 volts. Since the standard cell potential is positive, the reaction is spontaneous. The oxidizing agent in this galvanic cell is tin 2 plus aqueous ion because it gains electron and is reduced. The reducing agent is solid chromium because it loses electron and is oxidized. These are the functions of a salt bridge. Salt bridge helps to maintain electrical neutrality and complete the circuit by following ions carrying charge from the salt bridge to move to the half cells.